Hello and welcome to the second part of programming games in C for the Vectrex. Today I want to talk about music, or in general music, sound effects, audio, stuff like that. In the Vectrex that's kind of well supported, and we're looking specifically at two topics. First, music, and second, sound effects. If you look at the game Pong here in this example, you see it's quite boring, right? I mean, a game without a sound is actually just half of a game, I would say that. And so we first see how you implement the music. You remember maybe here at the beginning of our Pong example, we have this pragma constant, and that means actually to play a startup sound directly from the BIOS of the Vectrex. So far, it was not possible, of course, to hear something because, there was no sound implementation at all in Classics Coder. I have done that week. It's not yet finished or complete or perfect, but it works. And the challenge is a little bit to make it work on every platform without using kind of third-party libraries. So it's really all implemented native, but like that it works on iOS, padOS, Linux, Windows, and of course of macOS, like you see it now. So when we start up now, the Pong game, then you see we have a sound without doing nothing, right? But that's not the majority of the content of the tutorial today. So what I want to show you is how we implement now a sound effect, because if you remember the original game, it was always when the ball hits the wall, we have to play a sound, and of course also when the ball hits one of our pedal, we should also see some sound. So how we do that? Actually, with the helper function I implemented in Classics Coder, it's really simple. So what you have to do is to replace wait recall, which is a BIOS call at all, with wait for beam. That's actually is a helper function in the library of the Classics Coder. And now you can directly start by implementing a play sound. What is the best place now to do so? So actually we have here check ball position, and we already detect when it jumps top down or when it jumps left right, right? And that's actually the best place to integrating the sound. So to include now the sound, it's the same easy. So the only thing you actually are doing is when we have that condition here, we play a sound. I call it hit sound, that's just a name, it's a variable name. And I do the same here when it touches the border, right? The difference here is, of course I could play kind of different sounds. If it's on left side, on right side, I could use different sound if it touches the border, if it touches the pedal, but the system remains the same, right? Actually, that's all you have to do to implement sound in your game. But of course, if we check now the source, we don't have implemented so far hit sound. Actually, we need here some sound data, and for that we have different possibilities. The most easiest is to just create an array, define the sound, play it, you see the difference? Now we have a sound, and it always jumps in when it touches the pedal or when it goes to the border. That's more or less all we wanted to implement, right? Of course, the sound buffer here is, I would say, not very easy to understand at all. At the end, it's a specification defined in the Vectrex programmer's manual. It's defined what you have to do, what kind of bytes you need for the tone height, velocity, amplitude, when the sound is finished, and all that. And that gives an array of bytes. What I plan to do is including a little sound editor to create those sound buffers, of course, in a visual way, because it's really not so user-friendly to do so. At that point, it's maybe nice to know a little bit better how this all is working internally in Classics Coder. At the end, you have always two levels of integrations. One possibility is to directly call the BIOS call of the Vectrex, like wait recall, do sound, you name it, right? So all the functions we have also learned in part 1 of the tutorial. The second level is a level higher. So that means some kind of helper functions you can always use to simplify your life when it's all about integrating stuff like the joystick reading, controller buttons, or like now, the music. At the end, the wait for beam call is just calling two BIOS functions and one helper function. And if you look at the helper function, that's also not much what we do here. We just detect an internal flag of the Vectrex. That flag actually is saying if music is playing or not. It has some more states, but actually that's the most important. If there is a music flag, so if it's not 0, then we call a BIOS function. If it is 0 but was not 0 before, then we clear the sound and also clear our variables. That's all what is doing by update audio. Play sound is almost the same easy to use, because actually it also calls directly BIOS routine but stops the music before, because you have to handle that the way how the Vectrex is playing the music, in which order and so on. That's not implemented. But if you start the sound, it's all handled by the Vectrex BIOS itself, how long it takes, which byte comes next and have to be played, and so on. So that's really, really nice integration. So it really depends on you, what you're more like. If you directly access the BIOS functions, then it's a little bit more complicated and you have maybe also to read some more documentation. But on the other hand, it's more compatible to other samples maybe you find in the internet. If you decide, because you anyway write your first game, or you're just a learner about that and not so much interested about the internals, then always feel free to use the higher level functions like wait for beam, and with that you have really, really an easy life to integrate sound or other functionalities like calling the joystick or the controller, and more of course will come. So that was it already for today. I hope you liked to learn more about how to integrate music and sound effects in your own game. Give me a thumbs up if you like, and I also would like to have some comments, what you miss, what you maybe would like to hear more in future. And yeah, thank you very much for being here, and see you soon in the next part of the tutorial.